on the calculus of vectors. In this lecture, we'll see how the differentiation of vectors takes place, and we will be finally introducing an operator called as del operator, and which will take us further into gradient, divergence, and curl. In the calculus of scalar functions, ordinary functions, when we assume that y is a function of x, we are aware that the derivative of y with respect to x is given by a rate of change of y with respect to x such that the change in x is very, very small. So we can state that if there is a value of the function at some initial point, then we take a small change in value of the independent variable x, the function acquires a new value, find the difference of the two and divide by the change in value of the independent variable. So mathematically, I can express that f dash x, now f dash x here indicates the derivative of f of x with respect to x would be equal to the value of this function at a point x plus delta x minus the original value of the function at a point x divided by delta x. So I have the value of this function at some point of the domain at some value of x, then I give an increment to x, it becomes x plus delta x, the function acquires a new value, find the change in value of function, divide by the change in value of the independent variable x, this ratio such that limit delta x tends to 0 gives us derivative of this function at a particular point. Now the same concept can be brought into the realm of vectors. वहाँ जब हम vectors की बात करते हैं, there is not much change in this definition. The only change is कि जो quantity अब हम deal करेंगे वो एक ordinary scalar function नहीं होगा, it will be a vector function. So you are aware, a vector function is that which has a magnitude as well as direction. Force की बात हो सकती है, magnetic field की बात हो सकती है, electric field की बात हो सकती है, velocity की बात हो सकती है. So that's how we describe the vectors. Now think of a vector A, which is a general vector and is dependent on some variable. So this is a vector, and it is dependent on a variable u. So f of x now is a of u. If I think of the initial value of this vector, say at some initial value, the value of u was u, and then u became u plus delta u. So I could replicate the change जैसे हमने पहले वाले केस में किया. So I have the value of this vector function at a point u plus delta u minus what was its value earlier, so that is a of u divided by the change in value of parameter u, that is delta u, and apply a limit, that limit delta u tends to 0. This is how we can define that we have found derivative of a with respect to u. तो जैसे derivative of f with respect to x हमने लिया था, similarly we have now derivative of a with respect to u. तो ये इसकी definition है. U is some quantity which we will later on replace. We could replace it with some parameter like space coordinate जैसे x, y, z, or time like t1, t2, t3. Now this ratio which gives us the change in value of the function divided by the change in the value of variable can be seen through the geometrical process like this. तो अगर ये हमारे पास एक vector a था, so this was the value of this vector a at some value of the independent variable u, then it became a newer changed value, that is a u plus delta u. You will agree कि जो ये change है, this change is now as per the triangle law. The triangle law gives us that if this is one side of the triangle, this is second side of the triangle, then this becomes the closing side of the triangle, and that closing side gives the sum of these two. So I can call this as delta A. Delta A would be change in variable A, change in the vector A. तो अगर हम triangle law इसमें use करें, I get A of U plus delta A. तो two sides of the triangle being arranged in the same sense is equal to the closing side. The closing side is A U plus delta U. So that I have delta A equal to A U plus delta U minus A U. So that is the initial value of the vector at some point, and then the increment in value of U, that is delta U, the new value adopted by this vector, और ये difference जो है, this difference gives us the change in the value of A. Or finally, if I divide on left hand side by delta U, on right hand side by delta U, and insert a limit, that limit delta U tends to 0, here limit delta U tends to 0, और ये अब subjective है कि this limit must exist. So that way you have to have the existence of this limit. Now if this limit exists, अगर ये limit exist करता है, we arrive on this result. So that way this becomes derivative of A with respect to U equal to the function A U plus delta U minus A U divided by delta U, and limit delta U tends to 0. तो इसमें जो हमने invoke किया triangle law, that triangle law becomes an essential property of vectors which we have utilized in this case. So starting from the first derivative, हम higher derivatives भी इसी manner में निकाल सकते हैं. Suppose I have to find second derivative of A with respect to U, या third and higher derivatives. तो यही definition हम adopt करके चलेंगे, that gives the higher derivative. A very common occurrence is some space curves. A space curve is any path in a region of space, और अगर हम Cartesian coordinates use करते हैं, so a point on a space curve P could be a triad of three coordinates, that is x, y and z. So let's introduce a parameter, say कि जो इसका x coordinate है, this x coordinate is a function of some parameter u. Later on you could think of time as one such possibility कि अगर इसका जो x है वो time के साथ बदल रहा है. Similarly y is a function of u, z is a function of u, and so on. So ये जो space curve है, it would look like this in 3 dimensions. Here I am showing a 2-dimensional curve, but the actual path will be 3-dimensional. और इस 3-dimensional curve पर जो space में lie करती है, there could be possibility of finding a point here which is initially at some position, that is position vector r, and then this point is shifted to the newer position, or that newer position is a change in value of r through delta r, that is r plus delta r. So you will agree कि जो ये change है यहाँ से लेके यहाँ तक, this change from r to r plus delta r, as we did in the previous case, can be found by using triangle law of addition of vectors, and this is r, this is delta r. So r plus delta r, that means two sides in the same order would be given by third side taken in the opposite order. Now thinking of the value of r, we think of r as, say, r is xi cap plus yj cap plus zk cap. और अगर हम r को अब function मानते हैं u का, so I can write it as x as a function of u multiplied to I cap multiply plus y as a function of u multiplied to j cap, and z as a function of u multiplied to k cap. Now the moment I have to define the derivative of this, so we go to find out the change in value of r, change in value of r as compared to the previous change over a certain interval of change in the value of u. So if I say that I have to find out the value delta r divided by delta u, you will agree that this delta r can be found as, तो इस diagram को आप देखें, so I have the value of this r plus delta r minus r, which was the initial value, this is the final value, और r जो है, I have not written the subscript u, ये function of u है, divided by change in value of u, so that this change if taken such that limit delta u tends to 0, limit delta u tends to 0, अगर ये limit exist करता है, if this limit exists, then I have obtained dr over du, and this is the derivative of r with respect to u, and on the right hand side I have r plus delta r minus r divided by delta u limit delta u tends to 0. Now if I replace this u as a time parameter, that means you are studying x as a function of time, y as a function of time, z as a function of time, then so if u is time, अगर ये time parameter है, you will agree with me that this ratio dr by dt in that case becomes velocity. And where is the direction of this dr by dt at each point on this space curve? The direction of this dr by dt, which is velocity of the body at each point on the space curve, is along tangent at that point. So it is tangent at this point, or tangent at this point, or tangent at this point. So in that sense, we can also describe acceleration of the particle. So acceleration, which is derivative of velocity with respect to time, would be second derivative of r with respect to time. So accordingly, जिस तरह से हम ordinary scalar algebra या scalar calculus करके आए हैं, we have to adopt the same definition, but maybe the tools may run into some slightly bit complicacy, क्योंकि जब हम एक वेक्टर की बात करते हैं, we are dealing with direction as well as magnitude, and this algebra is going to bring us to some of the common properties of or common formulae which we use in the vector calculus. Now all these formulae will arise from the ones which we have derived in the ordinary calculus by using ab initio method. जैसे हमने ab initio method से कुछ formula लिए हैं. For example, if I have u as a function of x and v as another function of x, then we are aware of some of these formulae. D over dx of u plus v would be equal to derivative of u with respect to x plus derivative of v with respect to x. If I have the plus sign replaced by minus sign, so this formula becomes true for subtraction as well. तो ये minus हो जाएगा. If I have derivative with respect to x of uv, then it would be first into derivative of second plus second into derivative of first, and so on. Similarly, if we have a derivative of u v w, I have w as another function of x, then this would be derivative of u with respect to x multiplied by v w plus derivative of, so it is u, derivative of v with respect to x multiplied by u w, or we have plus derivative of u v into derivative of w with respect to x. तो ये सब फॉर्मूले हमारे पास हैं for the ordinary scalar algebra or scalar calculus. We have these formulae with us, और इन्हीं फॉर्मूलों को अब हम replicate करके देखते हैं कि what happens in case of vectors when we apply the differentiation to vectors where vectors are either added or subtracted. So we go for it now. So thinking of d over say du of a plus b would be derivative of a with respect to u plus derivative of b with respect to u. It can be also a minus sign here, that will not change. Similarly, if I have derivative with respect to u of a dot b, so this would be derivative of a with respect to u dot, so that way we have this derivative found, so this will be dot b. Then we have plus a dot derivative of b with respect to u. You have to be sure कि अगर एक डॉट प्रोडक्ट है, डॉट प्रोडक्ट इज कम्यूटेटिव, आप ऑर्डर ऑफ एडिशन चेंज कर सकते हो, बट इन केस ऑफ क्रॉस प्रोडक्ट यू हैव टू बी केयरफुल. So let's say if I have derivative with respect to u of a cross b, here I cannot change order of these two vectors, so it will be derivative of a with respect to u cross b plus derivative of a cross derivative of b with respect to u. So be careful कि a must precede b because this operation is not commutative. Similarly, if I have derivative of a dot b cross c, so this is scalar triple product of three vectors, so this would be derivative of a with respect to u, this derivative once found, dot b cross c plus a dot derivative of b with respect to u cross c. So I am applying derivative to the individual terms one by one and adding the result. So I have a dot b cross derivative of c with respect to u. So this would be the result if it is derivative of scalar triple product a dot b cross c. Similarly, we can have a formula for derivative of the vector triple product of vectors, that is a cross b cross c. So the result will be like this, that if it is d over du of a cross b cross c, here it is significant that we have to first define that which of these two cross products is to be taken. तो जो ये bracket में term है, this cross product must precede. So I have this result as derivative with respect to u of a cross b cross c plus then I have a cross derivative of b with respect to u cross c. So remember here that once you differentiate b with respect to u, take the cross product with c, then the result is to be multiplied to a. Same way, I have a cross b cross derivative of c with respect to u. So here, पहले आपको derivative of c निकालना है with respect to u. Whatever result you obtain, take the cross product with b. फिर जो ये result है, it will be multiplied to a. So these are some of the formulae which we will be using in our treatment of the differentiation of vectors when they are added, subtracted or multiplied. We will not come across the division because we don't accept the division of two vectors as such as the valid operation here. So you are content with the multiplication, addition and subtraction. And if it is so that we have a function which is a scalar function, so I have a scalar function phi of u multiplied to a vector, so this is a vector a, then as usual it will be the derivative of derivative with respect to u of phi first found multiplied to a plus derivative of a with respect to u multiplied. So as we do it in case of the scalar functions, that it is u into v type, first into derivative of second plus second into derivative of first, first into derivative of second plus second into derivative of first. In this case also you can go for a commutative property because commutative property holds true. Be careful here that in case of cross product the commutative property does not hold true, so you must abide by that, it does not hold true. So earlier we have now talked about the process of continuity and differentiability. Let's see that how that property works in case of vectors as well. You understand that if a function f of x is differentiable at a point, it is necessarily continuous. So a function f of x differentiable at a point, differentiable at a point is necessarily continuous at that point. But the converse of this is not true. Converse not true. Converse not true. A very common example is f of x equal to mod of x. This function, which is a function continuous at x equal to 0, but is not differentiable at x equal to 0. One of the ways of testing the continuity of a function at a particular point, अगर ये one variable function है, so if I take the value of function in the neighborhood of x by changing x through a very small increment delta x, such that limit delta x tends to 0, the value must be same as the function which it had. So this value, if I say increase the value of x, I obtain a right hand limit. If I slightly decrease the value of x, I obtain a left hand limit. If right hand limit, left hand limit is equal to value of function at a given point, the function is continuous. तो ये concept हम two variable function के लिए भी use कर सकते हैं. So if I have a function now depending on x and y, then I say that if I give an increment to x and an increment to y such that limit of delta x tends to 0 and limit delta y tends to 0, then if this function has the similar value as f of xy, so this could be an approximate test of this would be the test of its continuity at a point. तो वेक्टर अलजेब्रा में भी हम इस प्रॉपर्टी को जरूर यूज करेंगे, where we think of that a vector function, if it is differentiable at a point, is necessarily continuous, and if it is the converse of it, that a function which is continuous at a given point, like this f of x equal to delta x, may not be differentiable there. We can talk about the partial derivatives of vectors. In a partial derivative, we think of a function which is, say we have a function of more than one variable, and in case of vectors, if it is that we have a vector A which is a function of x, y, z, so this will have a derivative with respect to x, a derivative with respect to y, a derivative with respect to z. जब हम इसको differentiate करते हैं with respect to x, we keep y and z constants. जब हम differentiate करते हैं with respect to y, we keep x and z constants. जब हम differentiate करते हैं with respect to z, we keep x and y constants. For example, मैं इसका derivative with respect to x ऐसे define कर सकता हूँ. So I have the value of this vector at x plus delta x, y and z remaining same, minus the value of this function which it was having at a point x, y, z, and I divide this by delta x such that limit delta x tends to 0. तो अगर ये limit exist करती है, you have obtained the partial derivative of a with respect to x, जिसको आप dou a over dou x कह सकते हो. So similarly, मैं इसका partial derivative with respect to y भी define कर सकता हूँ. So it would be the value of this function a. Now I keep x constant, y becomes y plus delta y z minus a x y z divided by, so we have changed the value of y, so divided by delta y such that limit delta y tends to 0. Similarly, for finding its derivative with respect to z, we have delta A. So we have derivative of A with respect to z, partial derivative would be equal to the value of this function, keeping x and y constant, z is changed. Then we had the earlier value of this A, we have x, y, z divided by delta z such that limit delta z tends to 0. तो ये जो partial derivatives हैं, they can be extended into the double derivatives as well, and then we can apply the normal definition of finding a double derivative and using different forms of vectors. Different forms में है, for example हमारे पास partial derivative हो एक sum of vectors का या difference of vectors का या product of vectors का. So say an example like this. So if I have the partial derivative with respect to x, partial derivative with respect to x of a dot b. So this is like this. So वही रूल जो आप पहले यूज कर चुके हैं, derive कर चुके हैं. So this would be equal to dou over dou x of a dot b. That is derivative of first multiplied by second plus first dot derivative of second. This would be the answer. I can also say that what would be the result in this case if I have A cross B. So this would be same way, derivative with respect to A cross B. Be careful of the order here. Then I have the derivative of B with respect to X and this way. So this way we have the formulae for partial derivative. अगर कहीं double derivative हो, let's take an example of a double derivative. So I can possibly have an example like this. I have A dot B as a dot product of two vectors and I am differentiating with respect to x and y. So say we have the second derivative now, partial derivative of this. So this is second derivative. Here we have y and x. तो इसको आप ऐसे कर सकते हैं. I can say we are differentiating with respect to y this derivative like this. So I have a dot b. अब ये फॉर्म आप यूज कर सकते हैं यहाँ पर, so that we have for this result I can use this. So I have derivative with respect to y of derivative a dot b plus, so this would be derivative of so this would yield. Now we are differentiating this term first. पहले term differentiate करते हैं और ये बनेगा derivative with respect to y of, ये already dou over dou x है, so this will be second derivative of a with respect to b. So derivative of first into second plus, तो पहले इसी term को अपने, so we are differentiating again, it is of the type u into v. So derivative of first term into second plus second term का आप derivative add करेंगे, so this will be dot derivative of b with respect to y. तो ये इसका differentiation होगा. Next we have the differentiation of these term now. So this will be again derivative with respect to y of first into second. This is second. So derivative of first into second plus now this will be a dot, इसका अब double differentiation हो जाएगा ये, so this will be d2b over d dou y dou x. तो ये जो result है, this result is the second derivative of a dot b. तो आप जो previous knowledge है, उसी previous knowledge को use करके you can arrive on these results in the same analogy as we have done it for scalar functions. Now we take up some differentials in case of the vector algebra. we take up some vector differentials. If A is a vector, then differential of A would be simply so this would be the result. Similarly, if we have differential of A dot B, so this would be differential of A dot B plus A dot differential of vector B. Similarly, if we have differential of A cross B, so this would be differential of A cross B plus A cross differential of B. If a vector A is dependent on the coordinates x, y, z, we can define differential of A as partial derivative of A with respect to x into dx plus partial derivative of A with respect to y into dy plus partial derivative of A with respect to z into dz. ये रिजल्ट हम स्केलर फंक्शन के कैलकुलस में भी यूज करते हैं, follows from Taylor series, and we can obtain the same result we can utilize in case of the vectors. ये कोई डॉट प्रोडक्ट नहीं, simply multiplication with dx, multiplication with dy and multiplication with dz, and this is how we define various differentials of the vectors, may be useful operations. So far we have seen that how the calculus of vectors, probably we have taken only differentiation so far, is almost similar to what we do in case of the scalars. You have to be a bit careful about the non-commutative property in case of cross product. You have to think of the triangle law, or you have to think of the vector algebra in terms of the properties of addition and properties of subtraction, and think that we are not dealing with the operation of quotient of two vectors or division of two vectors, जो यहाँ पर एक acceptable operation नहीं है. And most of the things which you are already aware about the calculus of scalar functions will be of use here.